They give us a point, which is negative 1, 5. They give us a slope, which is, well, I can write m equals 2, or I can say at 1, the slope is 2. And then the problem says, find or estimate the y value at negative 0.9. Now, this is an estimate, so I'm going to use my little squiggly lines. So the problem says, the scenario is that we don't know what g is. And so we can't just plug negative 0.9 into it. So we don't know what g is. We do know a point on g, and we do know the slope at that point. Those two things are exactly what you need in order to write a tangent line. You need a point and a slope. Okay, so we make a tangent line. I make a tangent line by going y minus the y value. What's my y value at this point? Come on, Stu, shout it out. 5. And then I say equals, and then I say the slope, which is, what's our slope right now? 2. And then I multiply it times x minus, and what's my x value right now at this point? Is at negative 1, okay? Oops, this is supposed to be a negative right here also. So we have our point. It's in our tangent line. And then I'm going to move the 5 over just because you should be used to, it's actually nicer to put it on the other side. So we have plus 5 over there. And I'm not going to simplify it. Can I simplify it? Yes, I can simplify it, but I don't want to. No, the problem just requires you to take that and then plug in the x value. We're going to find what we approximately get if we plug in negative 0.9. And so I go y equals, actually, I'm going to plug in negative 0.9 into y. We're going to say 2 times negative 0.9 plus 1. And then we're going to add 5 to that. My stews, what is negative 0.9 plus 1? It is 0.1. So I have 2 times 0.1 plus 5. What is 2 times 0.1? It's 0.2, right? Right? 2 times 1 is 2, and then I move the decimal over once. I add 5 to that. What's my answer? Is 5.2. That is your approximated y value. That's your answer. That's how you do it. That's it. Yeah, that's it. Okay, so let me show you guys really quick. I really want to give you guys a contextual or a conceptual understanding here. If we have a point at negative 1, 5, that's right here. And then we want to estimate what the y value is at negative 0.9. That's right here. Okay? We don't know what g is, but we have its point. We also know the slope at this point. The slope is positive 2. Okay? So I know, since it's positive 2, the slope, I know that whatever the line is, I mean, I don't know what the line it looks like, but it's going to be like this, right? It's going to go up. After this point, it's going to go up. Now, the real point could be right here, but my tangent line gives me a point right here. Okay, and that's because the y value is an estimated point. We estimated that the point at negative 0.9 is 5.2. That's what we estimated because we used the tangent line. We didn't use the actual curve. Why? Because we don't know the curve. That's linearization.